still having problems. Trying to mix that somewhere. I'm not seeing what it is.
There you go.
That's fine. Yeah, just do a quick test to see if you hear correctly. Okay.
How do you pronounce your name?
Francois.
Okay, everyone. So for our next talk, Francois is going to talk to us about the state of the graphics stack on DragonFly BSD. Go ahead, please.
Yeah. So I'll be talking about the state of the graphics stack in DragonFly. I'm a system engineer in a company called Tigeot. We're doing social media business intelligence, writing dashboards, monitoring all sorts of social environments to see what people think of various brands and so on. I'm an X11 and BSD user. I have been a DragonFly developer since 4 years now. And in particular, I have ported the DRM i915 and the DRM Radeon kernel drivers to DragonFly. I've also been updating the DRM i915 kernel drivers since then. DragonFly. DragonFly is a Unix-like operating system. It is a Unix descendant, a BSD descendant. It has been forked from FreeBSD4 more than 12 years ago now by Matthew Dillon, who was formerly an Amiga hacker and has been sort of the FreeBSD tech lead for a moment at the time. DragonFly is a high-performance and scalable operating system. It uses per-core replicated resources, not simply mutexes and like other Unix-like operating systems do. So many operations are naturally lockless. DragonFly has an innovative file system called Hammer, which makes possible some very interesting things if you're interested in disaster recovery. The file system retains all the history of the various operations. The file system is a database, and it's possible to replay all transactions and to have them be replayed remotely on a remote server somewhere on the internet, for example. So if you erase files on your desktop, you can go back to a previous snapshot, get them back. If you lose a server, you can recover the files from a file slave system in another machine, so it's very convenient. We also have non-resource intensive deduplication, which makes it perfect to store highly repeating data, and a second level SSD optimized file cache. Very useful, once again, for file servers and also database servers. We had one user which used it to process geographical data for the entire North American continent. It didn't fit in the RAM of the X.Org station, but it just bought 2 SSDs, and it saw like only a 40–50% performance degradation compared to having the entire set of data fit in RAM. So it's very, very interesting for some niche workloads. Now I will be talking about the kernel graphical drivers. The DRM kernel drivers are based on Linux. It's really a no-brainer when you think about it. Many people are writing Linux drivers. Nobody has ever heard of DragonFly in the graphical X.Org community. So we have to use Linux drivers. And they're also very complex and fast-moving targets. If we port in a traditional way Linux drivers to DragonFly by replacing all system calls, data structures, and so on, it's fine. We get something working at one point, but then it will be a tremendous effort to update them. So the best solution was to not port the drivers, but instead to change the Dragonfly kernel to behave like Linux. I'm working as a sysadmin in my day job, so I'm lazy, and that's the best option which allows me to stay lazy on the long-term scale. So we have a Linux compatibility layer. So the kernel driver think they're talking to a Linux driver, Linux kernel. They have their own sort of BSD license implementation of Linux. So for that, we have many header files. Many were taken from FreeBSD or other BSD projects. In particular, OpenBSD had the best DRM KMS implementation on all BSD systems 1 year ago. So once again, it was not really a very difficult decision. We also took a few functions or data structures from NetBSD, which also implemented Linux subsystems in their own operating system. And finally, we implemented some Linux subsystems locally, like IDR. IDR is probably the most important one. We have a few dozens of files in the DRM subdirectory. We have include ASM, include Linux, and so on subdirectories. We have more than 8,000 lines of code or comments in these files. The IDR implementation is elsewhere in the kernel, so it's probably 1,000 or 2,000 more lines of code. And all of that is under BSD 2 clause license. Mostly because the files I took from other projects were already under that license. The DRM i915 driver is now mostly synchronized with Linux 3.17, except some relatively important parts like the MST DisplayPort code. This one is really painful to get right, but the rest works almost out of the box. We have some critical fixes from more recent versions of Linux, like Broadwell, bug fixes, and so on. The DragonFly i915 kernel driver supports Core 2 to Broadwell GPUs. In theory, it could run on Pentium 4 hardware if we ever find a Pentium 4 with 64-bit mode enabled. But we only have Core 2 hardware. That's the oldest hardware we have to test. We don't have Linux Skylake support yet. It started to appear in Linux 3.19. We don't think it would be too difficult to add at this point. And many people were involved in that effort. So, of course, I did the initial port, and then we had a few critical guys who did very important bug fixes, like Johannes Hoffman, who managed to get the i915 driver running. Matthew Dillon, who pushed very critical virtual memory fixes. Emre Vadaz, who also was involved in serious bug fixes in the kernel. And the same for Remvedas Yacinskas. If we look at the history, we started to get interested in KMS in 2010. There was a G.SOG project, which sadly never produced anything useful. Then 2 years later, I started again with the port from the FreeBSD kernel. FreeBSD, at that point, I'd implemented a DRM i915 driver. And since the DragonFly kernel was originally the same thing as FreeBSD, well, it made sense to use the FreeBSD port. It took approximately 1 year to get it working. We had to implement cache management in the kernel, PAT support, which means page attribute table. By September, we noticed the FreeBSD driver hadn't been updated, and there was apparently no effort running to update it. So I started to continue the work, but this time basing it on Linux. It was kind of difficult to merge the two different trees, but I did it bit by bit, trying to keep things building and running. And by August 2014, we had Haswell support. And at this point, it became very easy to replay Linux commits. And now we are at Linux 3.17, and when we first got Broadwell support, it was in May. And our driver at that point was based on Linux 3.14. Now we also have a DRM Radeon driver. It also is mostly synchronized with Linux 3.17. This driver depends on the TTM memory management subsystem, which is really difficult to work with. Virtual memory management is difficult and it's very crash prone, so we still are only at the Linux 3.11 level for the TTM subsystem. And once again, there were many people involved, mostly the same ones as in i915. Michael Neumann updated the Linux Radeon driver to Linux 3.18, 3.11, sorry. And then Remidas Jasinskas updated it to be synchronized with Linux 3.17. The story is mostly the same as for i915. It was ported, the driver was originally ported 1 year later than i915. So I started in the summer 2013. By October, we had something building. If we tried to use it at that point, it crashed the machine. It took, once again, almost 1 year to make it behave. And then I stopped being involved in the Radeon driver. I mostly updated i915 at that point, and other people started to become involved and update it to newer Linux versions. The DRM MDGPU driver is also something which would be interesting to have. It only appeared in Linux 4.2, so we're not there yet. We will probably have to port it if we want to support newer Radeons, like these families. The Radeon families and code names and product names are always different, so it's a bit hard to know what sort of card you're buying and which families it corresponds to, so it's a bit mysterious, but all of that will be required for newer hardware. The DRM Nouveau driver is also somewhat interesting. Nvidia hardware was never really well supported on DragonFly. At most, we had 2D acceleration with the XF86 video NV driver, which was a purely Userland driver. And Nvidia or the x86 developers stopped to update it a few years ago. So by now, new Nvidia hardware doesn't work with it anymore. 3D didn't work previously, so almost nobody in the DragonFly community bought Nvidia hardware. We don't have any investment to protect. So it's somewhat low priority. I still played a bit with the driver, and it's very interesting for it contains some files with the same name, some C files or .h files, mostly C files, if I remember correctly. These files with the same name exist in different subdirectories. And the BSD build system is unable to handle that situation. For all object files are put in the same directory. So it's a bit stupid, but well. So for these reasons, DRM Nouveau porting is relatively low priority, even very low priority for some people. So we'll see. Well, if eventually we manage to catch up on the i9-15 and Radeon front, we'll probably have a look at DRM Nouveau. The VESA driver is not a kernel driver, it's purely a Userland. But it's interesting to have it for hardware which doesn't have kernel drivers. So it's the only way to use Nvidia hardware now. There isn't any form of acceleration, but if all you do is display Xterms or maybe a Firefox window, it's relatively fine. Don't try to play few screen videos or games or something involving 3D acceleration. It will just be too painful. Now we have, with the DRM drivers, we have a generic DRM layer. It has been neglected for years. We basically inherited it from FreeBSD and the old DRM effort, which started maybe 15 years ago. I'm not sure exactly of the history then. So it's in relatively bad shape. There are a few parts we've managed to update along the kernel drivers, like CRTC handling, EDID, HDMI, etc., and so on. And there are still much older paths in there. Probably predating Linux 2.6.26. We're not sure for Git history in Linux, it doesn't go that far. So the biggest missing features we don't have is DRM master and DMA buff. So if you have a laptop, for example, with 2 GPUs, only one has a chance to work. Userland software is based on the traditional stack we see everywhere in Linux and other Unix systems. But we use FreeBSD ports to create our packages. What we call a port tree is a repository of building instructions, basically make files, file describing how to get some software, where to download the tarballs, how to build them, and so on with checksums. So all that is necessary to create binary packages. We use the FreeBSD port tree as a base. But then we process it automatically with an annotation layer, and we do some automatic test and validation in order to be sure a port which has been committed to the DragonFly dports Git repository has been able to build and install correctly at least once. So we have more than 20,000 packages, and all of that is the work of mostly one guy called John Marino. Dragonfly doesn't have enough developers to be able to maintain a complete package building environment to match the more than 20,000 packages which can be built from the FreeBSD port 3. So more than 20,000 packages, mostly one guy to maintain that. Concretely, we use X.Org. We have the X.Org server 1.14.7. We know the most recent versions work perfectly. They still are not packaged. Mostly because they haven't been packaged in the FreeBSD port 3. We have relatively recent versions of the various XF86 2D drivers. We keep a separate package for the last user mode Radeon driver. It's still interesting to have it on some special hardware. We encountered cases where the KMS driver was too buggy to use on some hardware, but the last user mode driver still supported the cards perfectly, so we keep it. For the Intel 2D driver, we use the last version, the last released version. We know the Git master one still works almost perfectly. It's still not packaged. So we have probably an old version of Cairo at that point. Mesa is also relatively old, but that's what is in our packages. Mesa 11 is very promising. It works better on various hardware. I think as well it's much better with Mesa 11 and some Radeon cards also have better support with that version. At this point, our most important problem with Userland is the FreeBSD ports are becoming a bit stale. For example, they still haven't managed to ship the last released version of XF86 Video Intel. So for that case, I had to create a local port. So we use almost the entire FreeBSD port 3 with a few exceptions. And XF86 Video Intel is one of these exceptions. I just hope it won't become necessary to have to package other software in the same way. If we look at the user experience, 2D operations works fine. OpenGL also works perfectly. We have accelerated videos, desktop environments work without much trouble. We had some users who reported on the IRC channel or by email. For example, the Caddy support was like night and day between the current Dragonfly version and the previous one. We can play 3D games. Open Arena works fine and probably is quite fast. So the only sort of benchmarking I did was to look at the frame per second counter on a desktop machine. So 200 frames per second on i9-15 Ivy Bridge hardware. Some users have become interested in OpenCL, mostly scientists. The OpenCL library works fine with i9-15 hardware. We have more than a 90% pass rate on the test route and as well hardware. Still a few workarounds required, but it's very promising. Some people have become interested in Wayland also. Wayland is a bit mysterious for me. It's apparently a sort of X.Org server replacement which doesn't implement X11, so applications have to be ported. And at this point, we know Wayland is working with the i915 driver, but there are still some limitations, like having to be root to be able to read file descriptors for the DRM subsystem and input drivers and so on. There have been some changes since the last XDC summit. In DragonFly, we now have a graphical TTY emulator. It's a stupid in-kernel frame buffers thing. We have big non-initialized characters. It's not fancy, but it's easy to read, especially on little screen, small screens, or data center monitors with damaged VGA cables and so on. So it's quite useful. Previously, we didn't have any working TTY emulator. Once DRM KMS drivers were running, we could display 80 by 25 VGA characters in text mode. But once you started X.Org, you couldn't go back to the VGA mode. So all we had was a black screen or frozen X.Org image. But still, not many people complain about that. So for the kernel driver, there are some very difficult points. Mostly everything involving virtual memory. The Linux virtual memory subsystem is different than the old BSD memory subsystem, which has also diverged between various BSD operating systems by now. So it's hard to handle things properly without being sure of introducing critical bugs and having the machine crash if you do some operation without understanding why later. So it's a very difficult area to work on. And we also have the problem of the IIC API. That's one thing we inherited from FreeBSD. I know for a fact OpenBSD doesn't use it, but it's very difficult to use it in the context of the DRM drivers. The IIC API in DragonFly tries to, really wants to have a complete device tree implemented top to bottom, whereas the drivers create devices bottom to top. They detect, for example, video output and then try to recreate the entire management structures to be able to manage different monitors. That's once again very difficult to handle that part. If we look at the end user point of view, we still have some problems. There is video tearing when the mouse is moving and you want to watch YouTube videos. That's only a problem with the X86 video interval driver. We don't see that on Radeon or Veta if you manage to play a video on Visa hardware. It has been fixed in the Git master of the X86 video Intel driver, but since there hasn't been a release in ages, I'm now looking at creating my own releases of that driver. In some cases, we can have display corruption. It's particularly visible on whole hardware with GPU and CPUs being in different chips, like Core 2. I believe it's a problem of some memory zone which hasn't been completely correctly handled with regard to cache management. The i915 driver is very peculiar about cache management. And yeah, we also have started to use the Intel GPU tools test chute. Some tests show we are leaking internal kernel return codes. So we know we have some buggy IOCTLs. And our Linux implementation isn't perfect, but well, we'll try to fix it. There are also problems with the Radeon hardware. In general, newer Radeon models don't have any form of 2D acceleration anymore. They rarely want to use OpenGL everywhere, even for 2D drawing operations. And for that, we need a relatively new version of the X.Org server. We know the 1.17 version works fine, but once again, it hasn't been packaged yet. So some Radeon cards aren't accelerated. We'll probably have to package new X.Org server versions at some point, but I hope it won't come to that. So the future, yeah, we still have many things to do. The most important one is probably to keep synchronizing the DRM drivers to recent Linux versions. We still have approximately, I think, a 1-year gap compared to Linux. We also need to improve our general DRM subsystem. For some applications, really require DRM Master support, for example. Yeah, Skylake. Skylake could probably become important if every other hardware manufacturer starts shipping Skylake laptops. So we'll have to update the DRM i915 driver to at least Linux 3.19.
Actually, 4.3.
Yeah, that's the current version. But Skylake support started to appear in Linux 3.19.
Oh, in 4.3.
Yeah, I'm sure we want it, but
It's not enabled by default before 4.3.
yeah, that's not a problem. We can still to
You don't
use.
want to use even 4.2.
Yeah. Okay. Yeah. Now, I really agree with you in the end, but if we try to go straight from Linux 3.17 to 4.3, we'll have problems. We'll have tons of problems. So I really want to replay git commits slowly and be sure to keep things working with the smallest amount of difference as possible. So the plan is still to go to Linux 3.19 first and then continue updating the driver to more recent Linux versions.
But don't expect Skylake to work.
No, it will probably be horribly broken, but it's still better than nothing. So
The same as nothing.
yeah, but well, we will have less differences going from Linux 3.19 to 4.3. So I really prefer doing things in the little steps.
I was just saying that you're not expected to work, that's all.
Yeah, but existing hardware will continue to work. and that's very important in my book. For once we had the first part of the DRM i915 driver, it took us 1 year to get it working, and to get it working without crashing the machine after 5 minutes. So I really don't want to handle a big update like that. Yeah, so going back to the list of future things to do, yeah, we'll want to continue using formal test shoots to find and fix kernel driver bugs. So Intel GPU tools is a good thing, and I thank Alan from Oracle for he helped me to get it working by creating patches. We also want to see how performance is compared to Linux, or if it's acceptable in general. So we'll probably want to run some benchmarks, and for that, the new test shoot Martin presented before is very promising. And we also want to improve the TTY emulator, like, for example, making it able to display Asian characters or accented letters and so on. So there's an effort going on to create a UTF-8 terminal emulator. And finally, I want to thank all the people involved with the effort of porting and improving the graphic stack. So I was involved in the first ports of the kernel drivers, but many people improved them, fixed other parts of the graphic stack, fixed critical bugs, or updated important applications. So I'm probably forgetting many people, but at least I want to thank all of them. So that's it. Do you have any questions?
So did you actually get an implementation of I2C running, or are you still working on that?
I'm sorry, I have...
I2C, did you get it to run yet?
I2C, no. We didn't have time to re-implement I2C. We're still using the old IIC FreeBSD and DragonFly subsystem. It's a pain, but we're managing to get around it. So we'll probably have to change the API. We'll probably have to change the API, maybe re-implement the Linux I2C API, or port the OpenBSD API, which looks much thinner. But for now, we just didn't have time. See, all the effort currently is on updating the kernel drivers. So it's not perfect. It's not a perfect match for whatever is in Linux, but it tries to reduce differences bit by bit between the various versions.
You talked a little bit about the ways that you think it's feasible to continue tracking the Linux i915 driver on an ongoing basis. But one of the things that's interesting to me, and I didn't realize completely before being here, is just how many different people are all building Linux i915 derivatives. Do you have any thoughts on ways that the different i915 derivative communities can better interact?
Yeah, at this point, I think the best thing to do is to just use the Linux code as unmodified as possible. And most of the effort is in making sure we do things the same way Linux does. the most critical bugs we had were with the virtual memory subsystem. And it's really, really difficult to get that part right. And it's also very system specific. So we have many people involved in improving the DragonFly drivers, but that's not really something we can apply to other systems. The locking subsystems are different, the virtual memory subsystems are different. Well, for FreeBSD and DragonFly, they're still somewhat similar. So what we did could probably help you there. But what we did was also make sure everything was as close to Linux as possible. So if we have to upstream changes, it would be for something stupid like the pipe variable names which clash with something else in our kernel and so on. I think a better use of a better effort will be to make sure the test chutes compile, build, and run properly on non-Linux operating systems. To really be sure we don't do something stupid in our kernel drivers, or we don't ship bugs in some IOCTL implementations and so on.
So you mentioned the pipe enum twice now. If you're pulling this in from Linux, why wouldn't you just rename whatever pipe name you have now?
That's what we do.
Huh?
We rename the variables with
so
the
that's not
clashing
something
names.
you should be upstreaming to i915. You should be changing.
Yeah, yeah. We'll think about it, but well, actually, I managed to get some changes in the i915 driver, but it was by reporting bugs, and I don't remember who exactly did the code change, but I reported once a bug I had with a particular mainboard, and it has now been integrated in the DRM i915 driver for years. So it's in a sort of blacklist for this particular. I think it was an Atom board. There was a particular Atom board which reported it had an a LVDS display, and that wasn't actually the case. So that's probably the only change I was involved with, which landed in the i915 upstream driver. But then we don't. We still aren't completely synchronized with the upstream Linux code, so I don't really want to try to push changes with such a version gap.
Do you have, what's the state of UEFI video support?
UEFI, we don't have any sort of UEFI support. At this point, we require hardware to be IBM PC compatible. For if we don't have a BIOS, the bootloaders simply won't be able to load the kernel.
So given that that's likely to disappear in the next 2 or 3 years, do y'all have a plan for getting that started?
Well, we'll work on it when it will become necessary, or if someone starts the effort before that. But at this point, we think the graphic drivers are much better use of effort.
Right, but once you get to UEFI only systems, VESA is not going to work.
Yeah, so we'll have to get them working then. That will be a big motivation.
Fair enough.
Just further to that last question, in FreeBSD we have a UEFI video driver, and that's been a decent stopgap for the people who, Haswell Plus, who currently can't use the Intel driver. The frame buffer X driver works acceptably well for developers bringing up some X terms and a Firefox or Chrome.
This may be beyond your knowledge, but when you do execute services, do you do that in the bootloader, or do you do that after some kernel setup?
I think we can chat offline a little bit, and I can look up some stuff for you.
It's something that we're looking at in Grub, because after execute services, the video APIs and EPFI they disappear. All that's left is the pointer to the framework.
Right.
So there's some theory about like would you like to be able to do edit, would you like to be able to pick a better mode, but you can't do that after you've left boot services.
Yeah, so in FreeBSD, our loader, basically it does exit boot services and passes a pointer to the frame buffer to the kernel.
That's the front one. Cool.
Any more questions? Great, thank you.
Okay. Thank you.